Hello and welcome to Security, where I will be having a nice little chat about mobile device security. And for the interested audience, I will be having an exam that relates to this presentation in exactly a week. So why not get going and let's try to dig into a topic here that concerns a lot of people, especially regarding today's landscape, where we see mobile devices being explored for various purposes, such as when the municipalities in Denmark are electing new representatives for the administration. They will have to consider where they will get their political feed. And what is not better than using the phone? So here's a phone and doing this, and then stream or record some videos that will be posted on various social platforms. But we have to remember, EU has put on restrictions to political content in your feed. So Facebook and Meta, Instagram will not allow these politicians to feed the audience through Instagram with political content, but TikTok is still available, and a lot of people have in the past shown to have a lot of impact through TikTok as a political speech outlet. And when we talk about TikTok, we have to talk about phones. And when we talk about TikTok and phones, we also talk about the code. And that's what I'm going to present for you here in this presentation. So please enjoy my little talk here about mobile device security. So if we extend this topic and open it up, we will see some different kind of aspects when we talk about mobile security. So one of the major aspects, and that can perhaps lead us and help us narrow down the scope, because in this presentation I will try to scope down the essence of what we should be looking at. Yeah, what do I mean by that? I mean that I will try to take a broad view, and then see what can we learn, and then can we turn that into precision. So like go for the market, go from risks. So how does the market look like? What are the risks that we know of? What are some policies and controls that we can apply in order to help the business be secure against threats that are like presented through using different kind of markets? And by markets, let's elaborate on that. Well, we know that there are a lot of phones out there. We have been presented with multiple opportunities through our lifespan to make the trade-offs and try to make an informed decision about what device system should we apply and how much are we willing to pay. So in fact, we are more or less dealing with iOS, Apple ecosystem, or Android. That's more or less what faces the crowd, the millions and billions of users on worldwide. And that's also what we're going to focus on when we talk about mobile device security, because these are the major players. These are like the only players that make us like the ecosystem relevant to talk about when you talk about the market. So you have, when you talk about operating systems, well, of course we have different kind of devices, but Android is an operating system, iOS has an operating system. They have different kind of mechanisms that how they distribute. So that's also an important aspect here. So what are they? How are they? So we, first of all, we have the two distinct divisions. Then we have the business model and how they distribute the OS. And the OS is locked tightly into iOS, but operating system. But on Android, you have like opportunity when you develop hardware which iOS, Apple, they develop their own hardware, but Android, they will allow other manufacturers of phones to build their operating system upon the hardware. So they will be, so therefore we will also see here going on forward, when we talk about different kind of vendors, we will see that, and security threats, we will see that we have the Android phones, which is, and this is a Nokia-based threat report that we will see. So when we talk about risk, going like a little bit sneak peek into the risk, but I'll go back to the market just in a minute, but we will see here that Android phones, they are the most vulnerable system, or the most exploited systems. This is based on, sorry for not citing it here, but this is from a Nokia threat report in 2019, as I recall, but I will just post the link to the actual site down in the comments. But you will see that Android is the largest pie, and then we will see Windows and macOS. So these are also more distributed, heavily distributed, and worldwide. That's why also my assumption is that we see this huge exploitation vulnerabilities, reported threats. So when we talk about going back to the market, so now we saw that there were like, if we see it from a threat perspective, so we take that lens put on, and then we look at the market, we see that we have the threat report as a figure that we can compare and see that what should we focus here, what should our focus be. So we can see that Android, and when we talk about phone, we say iOS. So that's particularly what we should be looking at. So when we also go into these statistics based from the Gartner reports on operating systems used on a worldwide basis, we will see that, or the market share from 2016 going up 2017, 2020, 2021, we will actually see that there's a slight market share increase for the iOS systems. But still, now I wrote non-Apple, but we should discard this as Android operating system. So we see here, these are the players. Also, what we can be looking at, or what we should also be considering, and this is more or less in line what I was trying to underscore before, because you will OS, like it's like apple banana, so you cannot OS Android iOS, you will not be able to merge these, like they are not mergeable. So that's also an important aspect when we talk about the threats. So we will see distinct systems, distinct ways of doing things, also distinct way of earning money and getting revenue. And these are also important from the threat perspective, and from legal compliances that will affect these these stores or OSs, because they will offer different ways that you can download an app, and then that the app is the actual threat. But in the Apple system, you have, like, they are very strict in the ways of, or at least what we consider strict compared to what Google is doing, and Android. Google is Android. I forgot to mention that, but I can say that now. But Apple, iOS, so they are very strict in terms of conducting business. So they will try to get these 30%, or at least beforehand they were able to get 30% from people who are distributing apps. And we know all what apps are. Apps are applications that you download through the App Store on the OS. So people not knowing iOS, well, before Margrethe Vestager, she decided to, or the EU decided to impose some restrictions on the way that Apple was conducting business through the App Store. There was only one single App Store you could download Android apps for on the iOS. So, but now we have at least 5 different kind of stores or ways to get into that, and that was because of some kind of restriction in the way they were conducting business, or restricting app developers from allowing other ways. Like they were very restrictive in the way they were conducting business. What was allowed in the apps, because they will check more or less everything that's in the app you try to launch to their app store, and the app store will also need a lot of verification, developer license, and certificates that are ways of proving that you are who you are, and they will try to, because that's what's something you buy for the app store, and you will be able to develop apps, and in they will take a 30%, and now they have separated that to different kind of tiers. So you still have one tier with 30%, and then you have another tier with less percent, because they were being controlled by the EU, and they were forced to make other ways of downloading, which in return puts more threats to us, because you will have, as if you have to verify these apps, you will more or less, they will be more vulnerable if they were downloaded from third party and other ways. So instead of this streamlined process that were very strict from Apple's side, now they can potentially allow, there are more ways of allowing apps, and that will make us more vulnerable if apps are downloaded through that way. But you have policies, controls that can be applied, so you will more or less be able to secure that. But this is very important to remember, that the market has an effect on the laws, because the market is regulated in the EU, and you want to make fair competition, so they will try to. So you should be aware of this when you assess the threat of mobile devices. So this is just an iOS device. Google Play Store is another way of downloading, and this is more or less unrestricted. But they are, as I'm hearing, that they are approaching more and more Apple-like system for develop. But I think they can tailor that in different kind of OS, in Android OS. Okay, so if we move on to the risk aspect here, I have been addressing that a lot here now. We've seen the threat report. I would also like to show you kind of different devices that are, but we're concentrating here in the iOS, the Android OS. So let's try to look at some threats. So now let's be more concrete about what are we trying to protect against when we're talking about the mobile device security, because we will see different kind of threats to these systems, to these mobile devices, iOS or Android, and we will see that, for example, that we can risk the exposure of a backup. So somebody has forged your Apple ID credentials somewhere, and they are able to retrieve a backup from iCloud on your iOS, and now they are in the possession of the backup, and they can exfiltrate SMS messages. So this is the practical approach. So you have your system, you have the backup file, you will try to get the directories of the file into a files.txt file, and this is going to be the technical part here. So what it means, that we will just try to narrow down what the directory are. So we see that here on the display here, that we can see from the screenshot here, we have we find the backup there, the type F and files.txt. So this ultimately, when after we run this command, we will see that when we print out what is in the file here, we will see that there are the backup directory, backup, private var, mobile, library, application support, cloud, docs account, and so on and so forth. So we have different kind of paths here, and this is helping us in narrowing down and optimizing our search of the SMS database. So these SMS files are stored in kind of different kind of formats. So here we are looking for the SQL. We're searching for the SQL, something that says something about SQLite or SQL. So that's a little bit more easy to search for. So SQLite is the way that we'll see most of the OS or the mobile devices are storing files in the database format. So we put that into a database txt. So first we have the file txt, now we have the database. So we're now taking the files, a lot of lines, put it down to database types. So we got the files, then we got the database. So we're narrowing down like the lines with different kind of paths, and now we're putting into more concentrated, focusing on specifically files that contains SQL, and now we're doing the same with SMSs. So we're containing database files with SMS files. So ultimately what we get here is that we actually see here that we have some here in our sms.txt. We have finally found that SMS search index, something here that can be interesting to look at. So when we have done that, we will now be able to quickly go through we also see here from we can make the VCL, so we will see how many lines there are in here, so we can like make a statistics based on and help us narrow down and be more informed in our choices. So we located this, we found this directory, so we'll now go into the Explore DB, the browser for SQL, DB browser for SQLite. We'll find the SMS DB here through file paths, and we will try to open this, and we'll get this view here when we click the browse data and look for this. Press this tab messages that is found in here, and we can browse different kind of messages here. Call me please, hey Josh, and Opti. We will see something called the here the username is right, and the password is something bull 5u stop. Yeah, so we managed actually to get to find SMSs from these iOS devices. And here we can also go more. Here we can actually see some browser tabs that were here. We see salesforce.com, and we see some username here. And this is like we see the actual HTML file that is stored in here. Said nobody. So this is also something interesting. And I'll just get into how we found this. This is from the plist util, suspend state plist, and this will show us actual files, perhaps that were you managed to get the backup, and the person who perhaps forgot to have a lot of browser tabs open, and because they don't manage that. So when you steal the backup, you will or the perpetrator steals the backup, they will be able to actually go into these browsers, and find out what perhaps a password was for typing in, or sensitive information. This is considered sensitive information. And we can find a PNG here file that is with username, passwords, etc. So you'll get into this. Will be a nice information to have if you want to further steal information, or make some more social engineering perhaps. Okay, so this was the iOS, and this was the backup focus. So let's just make a toast here, and I'll take some coffee. Okay, so if we go further here, we will as we talked about in the start, in the very early beginning here, we had iOS, we had Android. So now if we flip the coin, go to Android, well, we have, I will go further on some other techniques, not exfiltrating SMS, but we have this called Android Debug Bridge. Sorry for just making the abbreviation acronym here, but I don't know. But Android Debug Bridge. This is allowing you to like access everything on the phone, and this is not, unless you have a rooted or jailbroken iOS device, you will be able to make these kind of things on an iOS device, but otherwise you are not able to access the root, and you're not access the folders, directories, etc. directly on the phone on an iOS device. And you can also use something called Corellium. Corellium is some cloud-hosted iOS jailbroken devices that you can explore, but they are, as we talked about, they're very strict. This is Also, they cost a lot of money, devices compared to Android, but you will get very strict security, and they are very high level of security. But here in Android Debug Bridge, we will see that we can explore different kind of ways in the Android phone apps. So here we will just download the Android Studio. This is freely available, and we will see that we will be able to generate a device here. And what is important to know that is you have to there are different kind of ways we could that are you make these enable these devices, so use or configure these, so you can configure them with Google Play Store, you can configure them without. And there are some different kind of benefits and trade-offs. There are more exploitability in the some of them that are without Google Play Store, but I'll just explore some where I have put the least configuration here. So I'll make the device, I'll turn it up, I will spin it up through the Android Studio, and we will see the device here appear as a phone as we did before here, so with apps. And then we will we'll go into the folders through your terminal, and you will have to also install some utilities that can allow you to interact with these devices through the terminal. So you will go into this folder called platform, Android platform, and /adb devices. And if you type ADB devices, have one running, you should see that the emulator, you will see this. This is the list, and you see here the device number. So, and we will be able to communicate through this shell command. So you will be able to write shell commands if you ADB shell and you have one device. Be sure to only have one device that is configured, I think, without Google Play Store, and then you'll have more access. That's how it's done. So we see now we have the able to communicate it. We can write some commands here, or just write nothing as I did there, and we can write the ifconfig, and we will get the interface, network interface like details here, and we will see the iNet, the IP address here, the mask, etc. I think there's nothing more interesting here. So, and we will see ID here. We'll get some kind of different kind of statement, UID, get ID, groups, etc. SD card here, SD card, net. Yep. This is through the shell commands. And we also see here that we will write su root, who am I root. So you'll have root access, and this is particularly done easily through Android, but I think you will meet a lot of more trouble through the iOS version, because the jailbreak, I think I tried to do it well, and you have to have a device that's enabled by jailbreak, and then you have to or you can get the Corellium that they have actually been sued by Apple. Apple is trying to put trials on them because they don't like people jailbreaking their systems. So here we can, going on with the shell here in the ADB Android Debug Bridge, we'll see that if we list here what is in this folder here, we'll see, and the permissions here, we'll see different kind of permissions here. So we have interesting access here. Going on, we will have you will use the find utility, so we can use this find utility to dig down for some APKs, and the APKs is the way that apps are distributed through the Google Play Store platform. So you will be able to install, if you have the APK, I'll show you that later on, but if you have the APK, you will be able to install apps on your system, or on your iOS Android device. Android device. So we'll see here, we'll try to let's see here, this command, so find name APK. I don't know why this too, but we'll see here this has some kind of effect here. So we'll see that permission controller APK. So what we get here is different kind of APKs here that we can see here. We have some SDK setup, we have some emulator radio config, carrier config, system UI, wallpaper grabber, APK setting, emergency theme picker, different kind of APKs here on the device, and we can package manager list packages. So we also see packages here, interesting stuff. What is installed here? Let's get the overview here. Let's get like an X-ray into the system here on our Android. We are trying to we are trying to protect company data or our own phone, the politicians, from being listened to. So we want to get the X-ray. We want to full information here on what's going on here, and that's so we will try to see here, is there anything suspicious, something that is deviating from the normal behavior, normal installs. So we can get that. We get that overview with these fine utils. So let's go into be more specific about some kind of app that we will like to install. So why not take the Telegram, the very infamous and famous Telegram app, and which is used for secure communications, encrypted communications. But I think the founder was arrested or held back in France because there's a lot of information there regarding geopolitical tensions and communications through from perhaps frontline soldiers, interesting people. So, and that's particularly why we also should care about mobile device security, because a lot of things happen on these phones and can be interesting to look at and also to protect against. So we'll try to, now we have the APK here. We see that I have a file here called with ending.abk telegram 1022, and we'll use this adb install, and then this is just the path of where it's located on my MacBook. So we'll see here now, after running this command, we'll be able to launch the actual app from the Android UI when you go into the emulator. Interesting stuff. So we can also confirm that we've installed it. Now you'll be presented with some opportunities here, and this will more or less this is also important thing about Android apps and in generally about iPhone, iOS, generally about mobile security, because they are better at it and now than they were beforehand. But we all know that we are asked to allow certain kind of apps to access different kind of data from the phone from other apps. So this is also your way and company's way to like make policies that say that you are not allowed to share contact information with other apps. So they are interested in you can be insecure and say allow. Well, it's easier, but you can also say don't allow, because you could potentially give. This was the permission which is found in the manifest file of the the Android apps, and you will also find this kind of information in the iOS. But you will through this you could actually allow permissions, and they could gather information about your phone call logs. Interesting information if you are a politician and you were descended or like you Chinese, or not to name any particular, but or you have to verify some kind. Yeah, you have to gather information about some kind of politicians in Denmark, or you were another nation state actor, and then you will want to dig into their call logs, because you will see who they were calling, and you could blackmail them potentially or find out who they were talking to. Let's go further here. Let's look for the uninstalled Telegram qualified name. So here you can uninstall the app again here. So you will go to the PM list packages, grab minus I, and then you will see here you'll get the shell. We'll through the shell again here. Packs manage list packages. Grab I Telegram. You get here Telegram, and you'll find the package name. Then you will have to take the package name and then write uninstall that telegram.messenger, and then success. So you uninstall. Now let's look at how we manage apps. So here we have the Telegram app again, and we have some information here. So which is not important. So we will say s shell. We'll clear and manage and clear data. So we can clear data from the Telegram messenger. We can force stop through this command, and we can uninstall here. Okay, so let's just make a toast here. So breakout.apk. So this is another game. Let's go quickly through it. It's also managing through Android debug bridge. So here we install it just as we did before. So now you can see another example of installing an app here. And now we'll go into some log analysis here, or gathering some logs here, which could be interesting because it's also from both perspectives, finding out about the users and as a threat actor trying to log information. So here you can see here we're able to log information. We'll see the information when you click. So that's more or less when you click an app. This should be compared to like writing messages or clicking. You will look for the behavior. You can see what the app is doing, and that's interesting information for us because if we have to verify some kind of application and Android app, then we can go here and then verify that what it's doing, look for the logs, see if it's not doing anything suspicious. While like this is a kind of dynamic analysis, seeing is it communicating with somebody, what is it writing here. So we get like this X-ray of information because history has taught us that it's not just looking at the code, it's also an easy way here to get in, see what actually is it happening while we are interacting with this app. Now it's a game, it's fun, but it could be more serious. And now we've saved the log files here to save log.txt, logcat 123.txt, and then we say we'll look at the log files here, and we will see different kind of timestamps here, and then we'll get an idea of what is happening here. So it's AS playback activity monitor, audio server log, FX API begin playback. So this was perhaps some buffer pool access. This is some perhaps some interesting information. This was more friendly here, but file error accessing recent directory doesn't exist. Okay, so there's here we see some interesting things here. So failed logger transaction failed here. So yeah, that's interesting to know about when we should have apps on the phone, to know about what are they actually doing. Yeah, and then we can an interesting file here. So let's try to go through the ways of downloading, because if we want to examine an app, well, here we start by downloading to the so this is more about the static analysis. So here we try to go in and download an actual file from the browser through the browser. This is not always easy, but here I found an APK here from the AES File Explorer that has some known vulnerabilities in it, and here we install it. It was some way back. It was showing that it has some very serious vulnerabilities that really demanded patching. And we saw downloading here from one side, installing the app, and now we can perform some. When we know we can download the app through the browser, we can use the Jadx-gui to make static analysis, and that's another way of accessing what is the risk of this app. Trusting and vetting these apps is like through static code analysis, because they can have malware in it. So we will see here that we have the Mozilla Firefox plugin APK downloader. We will locate the name of the APK, and then we will try to download here. Found the APK. We'll press the download, and we'll unzip it. And when we unzip it, we can use the Jadx-gui, launch it with this command through the terminal. When it launched, we will try to unfold the APK from TikTok, and then we'll see these folders here, and we see a lot of numbers, a lot of letters that are not really saying anything, but this is way of obfuscating code. So we'll not get obfuscation, means that there's something going on, but you will have very hard time finding out what's actually going on. So besides from code that often code has the names of files are in a way that makes sense to a programmer. So a file would about like some kind of search bar. So they will search bar dot something, and then like what is the function of this? But this is really ABC that says really as little as possible, because you have to have some names. You cannot just unhide it. So you have to have some names that and that indicate a file, indicate a method here. Method is what is like running. That's the so like method I'm using running is the method. So here we see that there's something about database, so we can at least, there's a little bit of information, but it will take a very, very long time if you want to really know what's going on. But so this is, and this could be used for what we call reverse engineering. That's what it's made up, like against reverse engineering. Well, then you obfuscate the code before you distribute it. This is very common practice. But we can deduce something called here. We have some kind of ID here that's to a database. So that's interesting. That's also a way of launching malware. Threat vector is like looking legitimate app, having an app look legitimate. We've seen that. I will come in with an example, and they will distribute it. They will, when they download it, they will distribute code that is run after downloading. So download from kind of database, and that's where dynamic analysis, as we saw before, could be interesting, because it could perhaps detect that there's something static analysis not can find is code that is just like launched afterwards, but that will the dynamic analysis help us with, and with logging the activity. We've seen that Jadx-gui has found some Microsoft vulnerabilities that were not that were only detected because they saw some network activity that was suspicious when they tried to run some of in their lab. Jadx-gui is like a security company, and IT security company, very serious business. So we see here some kind of interesting information here. What it really is, I haven't digged into that, but we see that it's gathered some kind of ID timestamp metadata. So, but yeah, and we can go on from Jadx to use this MobSF is more it's more report friendly, so it's more easy to get an idea of what the threat is and compare that against other very quickly. So it's like automated tool for threat reporting. So we see here it gets a threat score. It's very nice. There's very good metrics here, interesting metrics here. 45 out of 100, and we'll get some information here. Who's the package name, musicality? Like we can verify a lot of things here. We can get an idea of who's distributing this, when it's released, etc. So we can also compare this. I think it's interesting to other apps here. So here we have some from my teacher here has distributed car scroller. So we see a threat score of 53, 44 here from EC, which has vulnerability, which we saw before, and 45 here. So this actually is more as a worse security score than this one, but this really ultimately has the highest score, and this is used a lot about of people using this. So, and we also get here statistics and interesting metrics about export providers, exported services. So that's communication outside and what's allowed here, and yeah. So what's the OS is allowed to do, or the app is allowing here. So here we get some kind of information here about these kind of vulnerabilities. These are actually also could be like a vulnerabilities, and these are serious, need to be monitored. We have like these 4 different kind of categories of exported data. So you can so you have some export receivers, you have some export providers. So that's a way of interacting with the operating system based on the app. So what is the app doing? What is the app like? How is it communicating these 4 different kind of ways in a Android system? So let's go a little bit more deeper in this. We can see here that it's also asking for permission here. So write external storage, and this permission is is considered dangerous. So this is from the TikTok app. Allows an application to write to external storage. So that's pretty serious, that it can go in and modify, delete external storage contents that can alter the integrity of the system, get some interesting data that we don't want to expose. So also here we see some read media. So allow reading files from external storages. So if you plug in, then it will be allowed to do that. That's invasive. And here we see what I was talking about before, which is also interesting when you look at the threads here, is the manifest file, where you see actually all the permissions here allowed. So permission, internet, record, reorder task, read external storage, write external storage, detect screen capture, system alert window. So it has a lot of permissions here. And we are also able through the MobSF to inspect strings that are detected through the code. So this is also interesting because that will help us in reverse engineering. So we can see here, we can go in and look for some interesting kind of ways that they are displaying text on strings, like text in the code and perhaps on the screen to the user. So we can help us narrow down the scope of assessing the risk here and what direct impact it has. So here we also look at the malware permissions. So this is malware, what is allowed here, so and what could be exposed by malware here, or by somebody who's not some bad actors here. So set wallpaper, read contacts, wake log, etc., etc. So this is 30 out of, and then common permissions is like, it's a little bit less severe. So it's actually, so there's like 25 ways of exposing this, but exploiting malware way. But yeah, so it's serious. Like this is the TikTok app. So let's compare it with this car scroll app, which is like made for purposefully being like a bad app from my teacher. So here we see the car scroller here is like 14, and here's the 30. So the score is one in difference, one less here in the TikTok app, which is used by a million people and politicians in Denmark to get elected from young voters. Okay, so now we've been through some technical stuff. Let's look at the more interesting malware. So we've been touching this topic, and now we see that we see the price on malware, we see the price of developing malware, finding malware holes, and if you are able to develop this in 2016, you could be rewarded with $500,000 for Apple iOS. So let's skip ahead to to 2019 from Zerodium. Zerodium buys these exploits, and you could sell them an Android 0-click and iOS 0-click. So Android got above iOS, and you could get like $2,500,000. That's how much it's worth to, and there you could. It's rather lucrative to be in the malware development business. So let's just look at a graph here that could like symbolize this or show this in a more visual way. We see here the price and the payouts are exploding since they launched, and now in 2025 they're not disclosing anything. So these prices anymore, they're just giving you this public key to communicate them with securely. So perhaps that says a little bit about how perhaps lucrative it could be or impactful it has to been now, given the current geopolitics and the digitized world. So what is interesting when we talk about malwares, what are ways that could be used as malware by malware? So this is second stage payload, as we talked before. This is what I was talking about, that they are just there while it looks official, you download it, but after you download it, it will try to send malware that's not in the actual file, but it will send it to the app, and then it will be executed after downloading it. And that was shown in the quick SMS. So it had downloaded malware and used that second stage payload for two-factor authentication, code catcher, subscription starter. So you start a subscription that you will not like to, and then you will send the money, and then you use for spyware, so listening to what was going on and trying to figure out what the person who downloaded it did. And it was found out, removed in 2019, but perhaps eventually it was reborn in 2021. Interesting stuff. We also have, as I was talked about before, what's interesting about the backup thread is like catching an Apple ID, or phishing it. So you will see this. This is a official pop-up message that will try to get your password, and this is a phishing from perhaps some kind of website that will try to to gather your Apple ID. So you have very, very little opportunity to visually inspect this and see what is different from this. So if you're in a hurry or something, you will just write it, I assume. So one of the major cases of malware is the YiSpecter, which abuse these private APIs that are in the iOS system. So these can make calls. They allows the apps to call some kind of service. So it could be exposed because you can allow apps to call other service, and they will be able to like communicate with the app that you downloaded, and that or allow it different kind of things that is very highly vulnerable to you. So it exposed 2015 Springboard iOS, and you see here that now it's trying to allow you communicate with some kind of other service here that you would not like to communicate with, that you can expose information to. So they will. So here is and it's disguised as a porn site. So it was actually distributed through some kind of porn media or way of watching porn, because that's not allowed in China. So people could download this to watch porn on, but instead it was actually malware that was downloaded to them, and they could be listened to or whatever these people wanted, because they could abuse these private APIs to so circumvent the App Store and then inject malware to the phone and listen to people and surveil them in different kind of ways. And here we see also the case that was exposed with the WikiLeaks documents, Edward Snowden, that we see Citizen 4 documentary is a good way of getting into what was in it. And here we see here that that was exposed that information was collected from the Angela Merkel, Chancellor of Germany, phone, who played a major strategic role on geopolitics. So that's interesting. The NSA and the Americans could actually just tap into her phone and listen to what she was saying. So that's pretty invasive, and that's something that we don't want. We want to be secure against that, and that's why we use these kind of different tools that I've showed you before and assess the risk appropriately, so we don't let out information that should not be let out, and that we are secure of who we are communicating with, what we're downloading. So here we see that NSA tapped Germany Council for decades. Quite good, important information here. Yes, so a little more about the policies and controls that you can put in place to secure your company. So we have the mobile device management systems that are different kind of providers, Jamf, for example, which are mainly focused on the iOS ecosystem, which are big there. And we have also IBM that are able to manage mobile devices. This is a way of controlling, as a company, putting down policies and partitioning and controlling what's going in and what's going out on this information. And here you can see some screenshots